Last week I was at Home Depot and I saw they had these GE Link light bulbs. They were, I think, $14.95 a piece, and if you bought two of them, you got a substantial discount on the Wink hub that they're compatible with. The overall price was about $50 plus tax. It was $14.95 per bulb, and then when you buy two bulbs you get the hub for $20. So for pretty low cost you get a little home automation, not much, but you know, a couple bulbs and a hub that you can connect other stuff to. Wink hub's compatible with a lot of equipment apparently, but I'm not going to get too much into that. You can see the specs. Most interested right now in these bulbs. So I've got three of them in the house. I've been using them. They work pretty good. Bulbs are pretty cool looking. A little bit heavy feeling. They got big aluminum heatsink on them. They also have, you can see in there, the little antenna. Sorry for the lights right over. There we go. You can see a little antenna there. Very special looking lens to shape the beam as needed. And you can see the LEDs all sitting there around the edge. These provide very good light. They're 60 watt equivalent rated with a, I believe it's 12 or 14 watts input. I think it's 14. These are dry location only, and looking at the side, oh, they're 12. 800 lumens at 12 watts at 2700K, and like everything else these days, made in China. UL listed, and they're pretty easy to install. I already have the hub set up and a few other lights connected, and you basically just go into add product, go down, choose lights, GE light bulb, and I'm going to go ahead and screw this in right now. Click next, and this is going to get pretty bright pretty quick, so be sure your Wink hub is plugged in and within range. If already installed, make sure your GE light bulb is turned off. Okay, it's turned off. So we're going to click next. It says wait 5 seconds, screw in the light bulb, and then turn it on. So we're going to go ahead and turn it on, and we'll see if it connects. There we go. And then we'll see on the phone here in a second, it should say success. There we go. Give you a chance to name device. So we're going to go ahead and name the device. I'm going to call it the spare right now, since that's what it is. And done. Okay, click get started. Got it. So now we have the spare light, and if we tap it on, fires up, and you can adjust the brightness here. It dims pretty well. I do wish it would get a little bit lower than it does, but it's probably good enough for most uses. And that's pretty much it as far as how they work. They work great. I've been using them for about a week. You can set up timers as well. You can see the activity, and then you can also set a schedule to automatically turn things off and on. Go to day, create a schedule. So I'm going to say waking up in the morning. We'll set it early. So at 4 a.m. Monday, Thursday, or Tuesday, Wednesday, Thursday, Friday, set. And we're going to have the bathroom hall light turn on, and there it is. And you can actually select multiple lights. I did experience a problem selecting multiple lights as a group. Didn't work out so well. Only one light or two lights would turn on out of three. So now I just do them individually. And so I'm going to go ahead and set the name real quick. We're just going to call that weekday bath light on. So we hit done. And now we've created a schedule, and you can see the schedules lined up here. So you go through, then you would have to create one to turn it off. So I might turn it off at 7 o'clock, 7:38, whatever you want to do. It's pretty cool. You also have what are called robots, and you can set robots to right here. You have my location. So you can have it say when it detects me leaving my home address, it'll turn a light on or off, or when it detects me arriving at home, it'll turn a light on and off. I guess that's good for single people. If there's multiple people living in a household, it might kind of freak people out if you leave and all the lights go out when they're doing something. But that's just an idea of the robots they have. You can also do light robots, so when one light turns on or off, you can have another light come on. It's basically slaving lights to other lights. One thing about these lights as well is you can actually just turn them off and then turn them back on and they'll come on full bright. So if, let's go to the app here real quick. And turn the spare off, turn that one off too. So if you come into a room and the light's out and you don't want to get your phone out, just turn the light off and turn it back on. And it'll come back on for you. And then again, you know, you can control it as usual with the app. So that's pretty much it, just for the basic rundown on these lights. They're wireless. The range seems pretty good, but that's not really, I didn't want to do a review. I just wanted to show you how they worked. And I want to go ahead and tear this one apart and see what's inside. So on to that next. Alright, so I'm going to try to pop this light apart. If you look down inside here, you can see there's, they look like little clips that this plastic is clipped onto, and there appears to be some adhesive in there. But I'm going to try getting in there and see if I can't pry this thing open or explode the plastic that it's made out of. Yep, here it coming. Obviously won't be taking this one back to the store. Alright, so we got the little dome off. Some scratching and some marring there. And then the next thing to come off is, wow, that took no effort at all. This actually doesn't look like a glue in here. It looks like a heatsink compound. So we can see in here they have, looks like 16 ultra bright white LEDs. I got the little receiver antenna there. And this top board is screwed down, so I'm going to go ahead and grab the screwdriver and take those out and see what's inside. Alright, couple little screws here. Again, as I mentioned, this base is very weighty. Most of it, I'm sure, is an aluminum heatsink. And yeah, this was just on, so there may be charged capacitors inside of it. Gonna keep an eye out for that. And right now I'm just gonna move the lenses aside and see if I can get this thing popped up. It comes right up. But alright. There's the two in-feed wires. And then there's a couple of Phillips screws here on the side. I don't know what the... bet if I pull that off. Okay, so it's safe to assume the LEDs were soldered on after this was assembled. I'm going to go ahead and desolder those. And move the LED board out of the way here so I can get into the rest of the screws. Get my soldering iron heated up. Okay, so I'm waiting for the soldering iron to heat up here. Notice these are actually very nice silicone coated wires, not just, you know, something cheesy. You can feel it just the way they feel against your fingernail. So I'm going to desolder that and that one there. Try to clean it up a little better. It looks like we're pretty close to temperature. Or not. Alright, there's one. There's two. So we'll pull that up out of the way, and then I'm going to go ahead and take these two screws out here. I'm guessing this heatsink will slide up. There we go. And that leads us down into that. So if you really think about it, of course you need a heatsink, but not much to it. The electronics are all potted. It's a fairly soft compound. You could probably chip it all away. Don't know if I want to do that though. Kind of see down into there. I think you can see the little surface mount microcontroller. I don't think I'm going to totally rip this apart, but I might change my mind. Yeah, alright, I couldn't resist. So this is a one-way trip for this light, but maybe you can use it to control something else with this little board and the receiver and those two little outputs. Yeah, I wish I had something better to cut this open with. I do. I will be right back. Right. And we're back. Always make sure to wear your goggles when voiding your warranties with power tools. Get some of this out of the way. Green dust on everything. Okay, so let's see if we can pull that apart. Yeah, we're getting there. Look at that. Yep, almost dropped it. I'm going to go cut around here. Yep, might have went a little too deep there. It's alright. Alright, well, we're slowly getting somewhere. Stuff's peeling off pretty easily. At least on that side. And just keep picking at it here. Not going to get away without scratching up the board some, but oh, look at that whole big chunk coming off there. All sorts of switch mode goodies in there, it looks like. T-board. I'm not familiar with that brand. 16 volts at 100 microfarads. And Aishi 63 volts at 270 microfarads. And we'll just keep picking away here. Power resistor. It looks like this this little board is the wireless board, and it's a separate module from the main board. I'll try to clean that up. A little better and see what we find here. Probably not the most delicate tool to be doing this with. And there's some printing there, but can't see it really yet. Don't worry, I'm not planning on reassembling this at this point. So it's all about digging out this Scholastic silicone stuff and getting a look at all the components as much as possible. Alright, getting towards diminishing returns here on this dig out. Must be input filter capacitor there. Whew. Slowly but surely, huh? Well, I'm not going to feel too bad if I ever put my components inside a sealed box with no airflow. They can sit inside this silicone or silicone-like product and not have any problems. Certainly anything I do with them shouldn't be a big deal. Alright, so we have this little wireless board there. I can't see that, but I'll get a picture of it. It's just connected with these 1, 2, 3, 4 solder pads. Got a little crystal in there, the integrated antenna, looks like a ground plane, and then the actually that's just floating there, that's not even tied off to the ground plane, so it's kind of a weird segmented design. And I really want to see what this is, so I'm going to go ahead and desolder that and look at that part number. It's going to take a few minutes for the soldering iron to warm up here. Alright, so soldering iron is warmed up, and I'm just going to apply some solder to these 2 points, heat it up, and then hopefully that will be able to pull right off. There's 2. Oops, sorry you guys missed that. And we'll get the other 2 over here. It's kind of rolling around, so I'll try to get it in the shot. Alright, so the wireless board is now free from this thing. Get a closer look at this radio. It's got a 6-pin header of some sort. Can't read the number on that chip. I'll take a picture with the camera and maybe try it with the microscope. And well, we can look at the back of the board here real quick, see what this says. Oh man, I screwed up the... It's a GE part. Let's see if I can get this right for you guys. Looks like I screwed up with my scraping. It's a something MZ100 module, GE lighting, 4/15/2014. So that's pretty new. It's interesting. Looks like this board, I guess either that's a test point or it may have been set up for an alternate antenna type. I'm going to guess it's a test point right now, because if this was custom built to make look like a filament light bulb, then why would you need an external antenna point on there? I'd be curious to see if they use this in anything else, since it only has 4 pins, and it's, I'm guessing, power, ground, transmit, and receive. That would be pretty straightforward. So let me go find out what that chip is. I'll be right back. Alright, so I looked up that chip a little bit to see what it is. I couldn't find one exactly the number, which is MZ100-NAQ2, although I did find a 88MZ100 series. And they're manufactured by Marvell Technology Group. It's a ZigBee system on chip. And the 88 MZ100 is a 32-bit ARM Cortex M3 processor. So I may have actually lucked out. It's an MZ100 module. Couldn't find any specifications for the MZ100 NAQ2, but if you have anything, let me know. The next part we're going to look at here is, I'm going to not get too much into the switch mode stuff, but I'm just curious what microcontroller they're using. If any, for this part of the unit. And I thought I saw a microcontroller in here, I guess not. So what I'm suspecting is this little board is actually the whole microcontroller with the built-in ZigBee radio, and that just drives this output transistor here to turn the LEDs on and off. All the switching is done with these little guys here, and I'm sorry if I got too close and made it blurry for you. This looks like a little switch mode controller. And I can't quite make out that part number. I bet you can see it though, can't you? There we go. You read that back to me? So that looks like pretty much what it is. It looks like a pretty sturdy, compared to some of the LED lamps I've seen, this supply looks pretty incredible. You know, someone else with more switch mode power supply experience could probably tear it apart and say whether it really is good or not. But if you look at some of these other LED light bulb teardowns, not the, you know, Internet of Things lamps, but just LED lamps, you'll see they have not anywhere near the same number of components. So that's pretty much it for my teardown of this bulb. I don't think I'm going to get that to pop out of there without doing a little more surgery, and there's really no point to it. It's just input filter capacitors down in there. So that'll wrap it up for this one. Alright, did everybody else leave? Good. Alright, I'm sure you guys wanted to see how bright these things would get. So I've got my constant current, or I've got my power supply set in constant current mode. And you'll see once we go up. Right now it's on constant voltage. You'll switch over to constant current once we hook up a load. I have it set for almost 37 volts at 0 amps, and I'll slowly turn up the amperage and see what happens. I'm going to screw this back on, attach a couple leads, and we'll go from there. Before I attach it, I want to show you on the back. This has some thermal heatsink compound, and doesn't look like a whole lot, but I guess it was enough. So we'll go fasten that on. Yeah, I noticed the capacitor in there was rated for 63 volts, so I'm hoping that these are designed to run around 30 or so, and that the capacitor was just double voltage. Let's take a look at that again. There's a 16 volt and a 63 volt. So we'll see what these LEDs respond like once I get a couple wires tacked on here. We'll go ahead, connect up our, go ahead and turn the power supply on. And we'll connect our load here. And I'll zoom back out so you can see the setting on the power supply. Try to get that wire. There we go. And actually I'll tilt that back up. So it's out of the way here. So we obviously need more voltage. I'll have to bring out another power supply that can go a bit higher than that. Alright, so I've switched to the HP 6274B DC power supply, 0 to 60 volts, 0 to 15 amps. Should be more than enough to light this up. And let you see the meters. We'll get this up in front of the camera. Stabilize it a bit. Move the camera. There we go. That should be good. Now you won't get to see me twiddle the knobs, I don't think, but that's alright. And go ahead and turn it on. I am connected to the monitoring terminals, which are only good for 3 amps, but that should be enough for this. 10 volts, 20 volts, 30 volts, and current set minimum right now. Up at 40 volts? Okay, just at 40 volts they're just coming up until the light here. And we're up at around 42 volts right there. Not even getting a draw on the ammeter here. Alright, so now we're on current control. And yeah, those can get pretty bright. I'm using the fine adjustment, but the needle's not even twitching over there. Nope, just barely. So that's about half an amp right there. Very bright, way brighter than I've seen these things get in the shroud. Let me see if I can get the, I'm not going to be able to get the lens on here. Hang on, I'm going to flip the wires around, drop the voltage back down, and push the wires through the heatsink. And the heatsink's not even hot. And the LEDs are pretty cool as well. Alright, so I got the wires run through the back here. And not touching. I'm going to put this diffuser back on just like that. Doesn't seem to want to stay. I'm going to put the, see if we can get this dome back on, see if that'll hold it in. Better leverage on this one. Alright, so we got the lens and the dome cover on this thing, so let's see what it looks like now. Go back up to around 40 volts. Overvolted the power supply. I have to turn it down a second. 42, almost coming up on 44 volts at minimal amperage. And amperage up. Okay, we're at 50 volts. Just about, looks like a third of an amp. I'm going to turn that back down, bring the voltage up a little more, or voltage limit. These look like they can get pretty bright. I am at 56 volts at 1 amp. And hard to tell how those LEDs are holding up, but I don't see them quaking in their boots, so to speak. So that's max voltage, max current of these LEDs that I can do on this setup. Whoop. I stand correction, hang on. I ran out of room on the fine adjust on my supply. Yep. That's how the LEDs start to shift color. I'm at 50, 52, 54, 56, and now they're drifting off and they're fading out. So that means too much current. They're really nice and white though. So I would say the voltage of these maximum is really going to be about 50 volts, 52 volts. Somewhere in that range. But I'm going blind staring at this thing, so that's enough of that. See how the heatsink, oh, that heatsink's really pretty toasty. It's not impossible to touch, but it's not comfortable. So yeah, dumping a lot of power through there. Alright, so that's that.